everybody. So right now I'd like to talk about digital signal processing, and let me get this out of the way. To talk to you about what it is and how to use it, especially in logic. And we are going to, so I'm going to give you some hands-on demonstrations that you can do yourself in multiple different DAWs, and also just talk about what digital signal processing is. So before we get into digital signal processing, let's talk a little bit about signal processing. So what signal processing is to change a signal, basically. And in the analog domain, that means we're changing the electric signal. And in digital domain, that means we're altering data in some way. And I've talked about this in a previous stream, but there are really different plugins for digital signal processing that can do signal processing in different formats. So VST is a format that can work on PC or Mac or Linux. DirectX isn't really used very much. AudioSuite or .au is the Mac format for plugins or audio units. TDM or AAX or RTAS are all by Avid, meaning that they're made for Pro Tools, designed for PC and Mac. Actually, let me just show you the where those are on my computer. So if you, on a Mac, if you go to Macintosh HD, your drive, library, audio, and plugins, these are all the plugins that I have hosted on my computer right now. So I have components, and these are the Pro Tools plugins. I have HAL drivers, and MAS, which aren't really used. Then I have VSTs, which can be used on Mac or PC or Linux. And then I have some updated VSTs. So I can download and put VSTs or put plugins into these folders on my computer, and then I can use plugins that I find for free on the internet. For example, these plugins are all made by Tom Erb, the creator of SoundHack and some other great software. So plugins, there are plugins that are made for different DAWs, like Pro Tools has its own built-in plugins, Logic has its own built-in plugins, etc. And they each have their own different name and file type for each of those plugins. So next, how to route things. So basically there are two ways to apply a plugin or an effect on a sound. So this goes for anything, so for analog and for digital. Basically, you can put a processor directly in a signal path to alter the signal, which is like a guitar pedal. You have a guitar, there's mine over there. You plug it into a pedal. Actually, I literally have these things right here, so I'll just show you. So I have a guitar. My guitar has a TRS out, and that output can be put directly into a guitar pedal. And then I can have the guitar pedal then go into my amplifier, and I just punch this on to add an effect to my guitar signal. So at a very simple level, that's the way inline routing works. Anytime I send something through this pedal and the pedal's on, it will affect the signal. So that's inline routing. Parallel routing is whenever you send the signal somewhere else to what's called a bus or an auxiliary track or a sidechain or something like that, so that you have the original signal going through dry or unaffected, and you have another copy of the signal going into that extra output that has the effect on it, which will look something like this. So we have our we have our output going through the channel. Then we have a separate send where multiple things can be sent to one effect. Let me put my mic back on here. An extra send where multiple things can be sent to the same effect. So really quick, let me just show you an example of that in Logic. So I was just messing around recording some stuff on guitar before I did a stream today. So, chill jams. Actually, I'm going to do a couple of things to this. First, I'm going to normalize these tracks because they sound a little bit quiet in the context of my session. So if I double click, it will pull up my track inside of the editor window. If I press File, Function, and Normalize, it will take the hottest part of the most signal that I have in this track, and it'll scale it up to 0. So it adds gain to every part of that track. So if I press normalize, you can see how, boom, it makes the whole waveform look bigger. So I'm just going to normalize each of these tracks. So this means that I could have recorded the levels slightly louder, but that one not really. The solo barely went up at all. So let's check out the level now. Yeah, a little bit better. Okay, so I want to mess with the solo, this part. So to me, this is still a little bit quiet. So I want to put a compressor on it. Now, in order to put a compressor using inline routing, I just go to the mixer window of Logic. So I can hold Command and press 2, or I can go to Window and open Mixer. And then on this track, the solo track, I go to where it says Audio Effects. If I click one of the empty spaces under Audio Effects, it will let me add any of these kinds of DSP onto my track. I want to mess with the dynamics with the compression. So if I press compressor, now I get this plugin. So I'm going to loop maybe a part of this that has some loud things and some soft things. And I'm going to reduce the dynamic range and turn all of it up. So now it's a lot more present. I'm going to check on the beginning. Okay, yeah, so it's sounding more present. I just put this one effect on my one track, so I have inline routing happening. Now, so let's listen to it in context. Okay, so that's an example of inline routing. It actually clipped a little bit, so it's good that I turned that down. So if I wanted to put an effect over a bunch of things at once, then I would use what's called parallel routing. So in order to use parallel routing, I need to make a send. So I'm going to send multiple things. So let's say I'm going to send this track and this track. I split these apart, but I want to send both of them also into a compressor. Maybe I'll use the same compressor on all of them. So then I could do send to bus number 1, and then I have to click and turn it up to 0. And I'm going to do the same thing on this track. Send it to bus number 1 and turn it up to 0. Excuse me. Actually, just to show you something a little bit more obvious, I'll put some distortion or something. So on this track. So I switched from track to track, but because I'm using a bus, they both get sent into this distortion. So check this out. So I go from this track being sent to the distortion through bus 1 to this track being sent to the distortion versus bus in bus 1, and I can see both of them come in here, and I can actually rename this track distortion. And this is my parallel routing for distortion. That doesn't sound that good, so but I will maybe mess with this a little bit to find a setting I like. So now I've got kind of a tremolo thing going on. I don't like that a lot, but you can hear how it's working on both of them. I think I'm just gonna turn the mix down on this. Let's see, something like that. Yeah, that's a little more reasonable. Okay. So those are the two different types of routing. We have parallel routing and we have inline routing. Most of the time you can use inline routing on basically everything, but let's say you want to send everything in your session into a reverb. It doesn't make sense to put reverb on like 80 different tracks when you can just send all the tracks into one reverb. It saves a lot of RAM, a lot of computer processing power. Okay, so the three types of signal processing. We have spectral-based, which is basically filtering frequencies, amplitude-based, where we change the dynamics, and time-based, where we basically make a copy of the sound and play it back after a delay to do all kinds of things. The two different things that I was just messing with are basically amplitude-based processes. So first, let's talk about spectral-based processing, otherwise known as EQ. So if you only learn how to do one thing with audio, other than, like recording or knowing how to use audio at all, EQ is probably the most important thing. If you know how to EQ properly, it will take your mixes and take the quality of your audio projects up basically 100%. So it's a really important technique in audio, in live sound, in the studio, in everything. So EQ is something that lets us exert control over the frequency content of a sound by filtering things out. There are a couple kinds of filters within EQ. You have a peaking filter, which is this bell-shaped curve. And how wide or how narrow the curve is called quality factor, or Q. And then we have these shelving filters that look like the edge of a shelf, right? And if you have a filter that looks like this, it's going to be cutting the lows and letting the highs pass by. Actually, let me do this the way that you see it. So the way that you see it, this is cutting the highs and letting the lows pass by. I'm doing this in a mirror. If it looks like this, it's cutting the... Wait. Let me do it on here. That's much easier. Much less confusing. So this is letting the highs pass and cutting the lows. This is cutting the highs and let the lows pass by. And if you have both a high pass and a band pass, then it creates what's called a band pass filter. Woof, man, that's confusing to think about in the abstract. So let me show you this in Logic. So right here, I have a drum set loop. So, still clipping just a little bit. Okay, so that's my loop. If I go onto my master channel, which in Logic is the stereo out, I can put an EQ on the master, meaning on everything. So this is a type of parallel routing. And let's listen to what happens whenever I filter out different frequencies. So if you've been in my class, you know that there are 4 different frequency bands: the lows, low mids, high mids, and highs. And you know that the lows go from 20 hertz to 200 hertz. So let's filter it so that we only hear from 20 to 200 hertz. So I'm making a low pass filter at 200 hertz. It sounds like we're hearing it underwater or something, because all of the hi-hat's gone, all of the brilliance of the sound is gone, because we're only hearing the low frequencies. If we listen to the low mids, which are 200 to 2000 hertz, basically we lose all the gravity of the sound, all the beefiness of the sound, and now we just hear this mid-range, this kind of like radio sound. So this is like listening, if I do this, now this sounds like we're listening through phone speakers. So if we listen to the high mids, which is 2000 hertz to 5000 hertz, there's not a lot of energy here. It's mostly the cymbals, the ride cymbal. And then lastly, we have 5000 hertz to 20,000 hertz. Which is just the hi-hat. We basically can't hear the guitar in this at all. So the way we filter, here's everything together. So the way we filter and treat different sounds, different tracks using EQ gives a completely different flavor to those sounds. So a lot of the skill of engineering is making sure you have good signal coming in and then balancing the signals with each other using EQ. So changing the center frequency of the EQ and changing the slope of the EQ is really important for using these shelving filters. And for analog EQ, there are 4 types. And in digital EQ, we use some of these types often. So parametric EQ is basically the most customizable type of EQ. For every, we'll have a shelving filter in the high and a shelving filter in the low, and then we'll also have multiple peaking filters. And those peaking filters will be able to change the gain, we'll be able to change the quality factor, or how narrow something is, and we'll be able to change the center frequency to move it around. So basically, if I jump back to Logic, this is a parametric EQ because I can change the width, I can change the gain, and I can change the center frequency. All of that's true. And I also have these shelving filters. So if you have access to all of that stuff, that's called a parametric EQ unit. This is a Millennia preamplifier, Millennia stereo EQ unit. This thing is expensive. It's maybe $5,000 or so for one analog EQ unit. So it's a lot cheaper to use these in digital format. Here's an example of a parametric EQ unit within Adobe Audition. So again, you have access to quality factor, frequency, and gain for multiple bands in multiple places. This EQ unit has multiple names now. So this used to be called graphic EQ, but now we usually call it notch filter EQ because it's a bunch of notches together. And in mixing, EQ can be used to change the color of an individual instrument. It can be used on a bus to change a bunch of signals. So this is an example of parallel routing. And it can be used on the master fader to change the overall flavor of a mix, which is a mastering technique also that uses parallel routing. Just a reminder of the 4 different frequency bands. We've talked about these before if you've been in a class of mine, but they're important. You should memorize them. These are actually simpler forms of the frequency bands, but this is a good place to start anyways. So this notch filter EQ or graphic EQ, these were usually used in live sound to reduce feedback. So if you can find which frequencies emphasize feedback more than others in your system, you can just adjust them slightly using notch filters so that you can turn everything up a little bit more without getting feedback. It's really useful. There are a bunch of frequency guides of how to EQ different signals. Really, you should learn to do everything by ear, but this is a good sort of starting point. There's also in Pro Tools and Logic, there are different presets. And these presets, you know, they're usually not great, but they do exist and you can use them as a way to kind of get started. So like here's my, here's one of my guitar tracks. Let's try some preset. Guitar, well, picked electric guitar, that's what I have, so. It's not bad. I would adjust it to be something like this. Yeah, something more like that. So, but the thing that it gave me as a preset, it was in the ballpark of what I would do for an EQ, but it just wasn't quite there, right? So use these guides, written guides that you can find on YouTube, guides you can find via Google, and also the guides within plugins as a place to start for whatever you're mixing, and then go from there. Tweak it by ear so you get the best possible results. So one way of understanding frequency in general is knowing that each musical sound that you get it's both musical pitch in one sense, and it's also frequency in another sense. So if you can learn to hear and learn to memorize different sounds as frequencies, then you can know how to EQ them. So for example, if my guitar over here, I know that it's tuned in a specific way. So I know that my guitar is tuned E, A, D, G, B, E. And I also know that this A is A 220 hertz. Actually, no, this A is 110. 110. So the note A440 is about right there. So for me as a guitar player, if I can remember that A sounds like this 5th fret on the 1st string, then I can learn to hear and memorize different frequencies of musical instruments and how they fit in to the frequency spectrum. And this is really helpful for learning how to EQ different instruments. So if you do play an instrument, look up what the fundamental frequencies of that instrument is, and use that as a way to memorize and get to know the frequencies of that instrument. So let's say you're a violinist, the low G string, look up what frequency it is. So next, time-based processing. So the use of delay to add perceived depth to something. So delay, echo, chorus, flangers, and reverb are all actually made using delay. So they're all, delay is the main source of all of these types of processing. So what digital delay does is it actually samples audio directly into the random access memory of your computer and replays it after a short period of time. And this is also used for a wide variety of results. So this was created originally using tape, which if you take more classes of mine, you'll actually get to use an analog tape delay. It's really fun because there's space between the record head, the place where the magnetic tape gets information imprinted on it, and the playback head where the tape machine takes the magnetic information and sends it to the speakers. Because there's actually space between these, physical space, that creates a slight delay between the recording and playback. So this is the origin of delay. And basically there are different results of delay depending on how long you wait to play back the sound. So if you just wait 1 to 15 milliseconds, you get these kind of phase and EQ changes, and things like combing, flanging, phasing, all happen whenever you have a very small delay and then playback. If you start playing something back longer than 15 milliseconds, you get this kind of doubling. And then longer than 35 milliseconds, then it starts to sound like an echo. Da-da, 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 da-da. So let me show you these in Logic really quick. I'm going to use I'll use the solo. I'll use something like this spot. It's the melody of my song here. So I'm going to use inline processing on this, and I'm going to go to, so click in a new plugin, and I'm going to choose delay. I'm actually going to use sample delay just to start in milliseconds. So if I put it before 15 milliseconds, it'll just sound like change in EQ. It's pretty subtle. You can really hear it when I move it around. If I make it longer than 35, I'm not hearing this very much. I'm gonna try a different delay. Try tape delay. There we go. Now this delay actually has the option of being synchronized to the tempo, which is kind of cool. In this case, I don't want to do that. I want to make it a lot smaller than that. So first I'm going to try 15 milliseconds. So still pretty subtle. If I try 30 milliseconds, you can hear a little bit of a doubling there, especially if I turn up the feedback. And then if I go longer than that, yeah. Something like that's kind of nice. So let me put that in context. So it kind of just makes it stand out a little bit. Let's say I also wanted to put, just for later, I'm going to make a little reminder for myself by copying this, because I want to put some effects on parts of the drum set. So I'm going to take just the side stick and I'm going to mess with this in a second. I'm going to put some reverb on it. But you can also hear that if I mess with the delay a lot, so like this. Actually, I like this. I don't want to mess it up. So I'm just going to make a copy. So if I start sending the delay into itself, letting it feed back into itself, it basically turns into this weird looping feedback machine, which is awesome. Everybody loves it. So even beyond these different options of delay, we have some other more dramatic, crazy things that you can do with delay. So the delay parameters, gain, mix, filters. So mix is really changing the wet-dry mix, which is what we call the original signal being the dry, and the affected signal is the wet. So you can use delay on multiple parts of your mix. It doesn't have to be super obvious to be effective. Another time-based process is reverb. And reverb is a signal that adds the characteristics of a room to a sound through reflections. So it's putting the signal through an artificial space. And there are 4 stages to reverb. So you have the direct sound. You have the sound after it reflects off the wall one time. You have early reflections where it's reflected a couple of times off the sound. And then you have reverberation or late reflections where sound has reflected everywhere else it's going to and finally arrived at where you're listening to it. So sound vibrating in the air, direct signal going from one place to the other, early reflections, and reverberation being the 4 stages of reverb. And there are 4 types of analog reverb. chamber, tube duct, spring, and plate. Chamber is basically the idea where you play back sound in one side of a room, of a space, and then you record it on the other side of a space. So you're listening to your signal through a chamber. And probably the most famous chamber reverb recording is the drum sound from When the Levee Breaks by Led Zeppelin. It was recorded in this English manner, where John Bonham was playing drums at the bottom of this big foyer, and then they mic'd it at the very top of the foyer. So you have this huge space that then you hear the reverb of. Let me try playing this on YouTube, see if it'll cooperate here. It is cooperating. So even just that. So listen to the drums really carefully one more time. So it almost has this reverb, da-da, da-da, dun-da, dun-da, da-da. That's actually, it's not a delay. That is a natural reverb of the sound going from the bottom of that hall to the top and back down. So it's the sound of the sound going to the top, to the mics and back down. That reflection is a really powerful type of sound. So that's pretty characteristic chamber reverb sound. So next we have tube duct reverb. This is not really done very much anymore, but if you played a sound through an AC duct, that gives the sound of this reverb. We have spring reverbs, where we're not talking about sound in the air, we're talking about electricity now, where you send an electrical signal basically through a slinky, through a spring and back, in order to get this special sound. This is really used on electric guitar quite a lot. So let's check out an electric guitar example of a spring reverb. I didn't know that I needed to hear this, but I really do. It's great. So refreshing. There's a lot of kinds of reverb on here. Listen for the electric guitars. They have a spring reverb on them. The snare has a different kind of reverb. So right there. So the characteristic thing about reggae production is having, especially in these old recordings by King Tubby, is the snare drum has a huge reverb on it, just this huge washy reverb. And then the melodic sounds like keyboard and electric guitar also have a different reverb, different size, different type. So the electric guitar will have this spring reverb, and then the snare drum, the drums in general, but especially the snare drum, will have a plate reverb on it. And a plate reverb, you're sending an electrical signal, but it's not through a little spring, through a slinky, it's through a giant metal plate. So it gives it a lot beefier of a sound, has more lows in the sound. Yeah, so if you listen to, there's a lot going on with this Phil Collins song production-wise. But, so once the drums come in here, sorry, I went over the break. So that sound of the snare is actually going into a plate reverb, and then it being tamped down by a gate, and then getting tamped down in time with the song. So it's this really big reverb, and then it gets just swallowed up. So you have this gated reverb that has this really fat sound. And you can listen to that in contrast to the reverbs in this King Tubby song, where the reverbs are huge and getting let go the whole time. A lot more spacious as opposed to a lot tighter reverb that's used in a very specific way to add depth to a sound, but not overwhelming, not washy. So the way that you should use a reverb in your own production is basically you put a reverb on something, on a signal, turn the reverb all the way up and make it all the way wet so that you can hear the flavor of it, and then basically back it off gradually until it sounds subtle, until it sounds just the right amount for whatever you're using. So let's do that on something. So what I want to use the reverb on is this side stick. That's it, just that one thing. Yeah. Sounds super lame compared to the Phil Collins kind of huge sound. So let me find a reverb here. I'm going to use this Space Designer reverb. I'm going to turn it all the way up, and I'm going to turn the size of the reverb up a lot. So yeah. And I want a plate reverb. So that almost sounds like a delay. Looking through these, percussion plate, let's check out how that sounds. That's not bad. It's pretty huge sounding. Let me make it a little bit shorter. Whoa. I can also add an EQ. Something more like that. So now let me integrate this one reverb thing into my track. So even if it's in the background, it just adds a little bit of this kind of background. It'll make the whole thing sound a little bit smoother, a little bit more mellow, because I've added one additional layer into the back. It's not bad. I like it okay. I think if I were going to add something else, I would take this cymbal hit and give it its own track. And I'll just delete it from the original here. And give it a different reverb than my other track. Maybe I'll just have it every 2 bars. So let me try messing around with this. So huge room. So now it kind of has a fade to it. I don't like quite that much of a fade. Sounds a little weird. So it sounds a little unnatural, but it's kind of cool. It's like it's got its own vibe going on. So listening to all that together. So we're basically just adding more and more vibes, like making this more and more laid back, which I like. If you want to make some lo-fi hip hop out of this, let me know. I'll send you the stems. So we turn the reverb all the way up, and then we back it off to make it more subtle. Let me back off this this cymbal hit a little bit more, just to see if we can get it into a more reasonable place. So that was subtle enough I didn't really hear it at all. Let me take it up a little bit more. Yeah, I'm liking that. I'm liking that. So it doesn't have to be obvious to benefit your session. So convolution reverb, check this. Well, actually, let's just watch it together. Is a special kind of reverb. Altiverb being the most famous type of convolution reverb. But what this is it takes the measurement of a room and then puts that room, your sound, into that room's reverberation using a specific technique. Logic, the Space Designer reverb, this actually is a convolution reverb. And you can, if you look right here, you can create your own impulse responses, IR sample right here. And you can use the sounds of any space that you want to go out and record using this technique. So let's watch this video about Altiverb really quick.
Hi, I'm Arjen, and this movie is all about Altiverb version 7. Do make sure you watch this movie in HD format down there in the YouTube bar. And if you can, use headphones or proper speakers. I'll use Pro Tools here to demonstrate, but Altiverb runs in most host applications. Here's Altiverb 7, the original professional convolution reverb plugin. It creates reverb by using actual samples of real spaces from all around the world. And as you see, Altiverb is bypassed now. If I hit play in Pro Tools, you'll hear some dry drums. When I switched Altiverb out of bypass, you heard the drums in the room that you see right here, which is Teldex Recording Studio in Berlin, Germany. So Altiverb applies the acoustics of a real room to your dry recording. It's a bit hard to believe. To do it, we need this. A click with a room's reverb tail. We get that click reverb by putting up microphones in a room together with a speaker. And because it's hard and dangerous to play back a loud click, we play back a sine wave sweep instead. We later calculate the sweep out of the recording, which gives us that click with reverb. Now take a look at one of your dry recordings. Zoom all the way in, and you'll find that it's a stepped line. Actually, each and every one of these steps is a click.
So if you've taken a class with me or you've learned about digital audio, you know that each one of those steps is called a sample, where that's a measurement of the audio that's come into your system, and that audio has been measured and saved using pulse code modulation as one representation of the sound. So it does that measurement 44,100 times per second, and then you have the digital representation of a sound. So that's what he's talking about. This thing is a click. He's talking about samples.
Clicks are pointing up and down at different volumes, but essentially they're all the same. Now all we need to do is replace each click from the dry bass by a scaled click reverb that we just made in the room. And then the bass will end up sounding like it's played in that room.
So this is a special technique that's very processor intensive, because it's not like you have a signal, you send the signal through a delay to make the reverberated signal. It's a lot more complicated than that. It takes this one impulse response and applies it to every single sample. So it applies it 44,100 times per second, which is a lot more processor intensive.
Then the bass will end up sounding like it's played in that room. To illustrate, here's that dry bass actually played back through our onstage speaker in the Antwerp Opera and recorded at the balcony seats. And here's how close Altiverb gets to that. Amazingly close.
So I definitely recommend Altiverb. It's a little bit expensive. Let's look up what an Altiverb license costs these days on Sweetwater. Yeah, $520. So that's pretty expensive as far as plugins go, right? But we do have convolution reverbs that come with software, like Space Designer Reverb from Logic. So you don't have to have the super high-end one if you don't want to. And just a reminder, yeah, we have these really interesting processes, we have these really cool effects, but these effects are only as useful as you can make them yourself. So you have to use your imagination, craft these sounds, carefully listening to them in order to get something out of these effects. Just like throwing something on there isn't good enough. It's not even close to good enough. You have to use your art, your artfulness in order to make these things work. Okay, so there's some pitch and time related effects, like changing the speed of a sound. So let me mess with some of the stuff I've got right here. So here's this track. Okay, so if I want to mess around with this, there's a bunch of ways I can do that. If I just go into my mixing window, if I go into pitch, there's a couple of things I can do. So if I go to pitch shifter, I can just shift the whole thing up or down. You can also hear that kind of like warbles. That's one of this weird artifact of pitch shifting. So this is done by basically re-recording the sound. I can also do pitch correction using Logic. So this is like a version of Auto-Tune. So it's taking what I played and it's remapping it to whatever scale I tell it to do. It's pretty funny because you can hear it working really hard to try to map all these complicated things. I'm setting it only to these pitches. So this is like the cheap and dirty version of pitch shifting. I can also just like slow the whole thing down. I'm not sure if Logic has a good plugin for this. Let's see. This is to change vocals. That's not super useful for us. If I go to, if I double click and go into this editor mode, I can use what's called flex pitch in Logic, which is this little icon right here. If I click that, it will it'll actually analyze my track. Whoop. Okay. So if I go to, let's see, functions, time and pitch machine. So now this is a whole other way that I can change my track. So let's say I wanted to change the tempo of it. So I want it to go from 68 and I want to make it even slower. It would sound like this. Non-transposition value. Ah, I see. So if I change this in transposition mode, let's say I take it down about half an octave. So this is like Alvin and the Chipmunks style. I just like slow it down or speed it up. Sounds kind of cool. Likewise, if I speed it up, sounds kind of like a ukulele. Now, the other thing that Logic has that's super powerful, I'm actually going to record a vocal because it's easier to hear with a vocal. Don't judge me too hard, please. Is what's called pitch shifting. It's kind of like Melodyne or like Auto-Tune. So I'm going to record something. Now I have to think of what I want to record. Oh, so much pressure. I think I'll sing My Funny Valentine. Yeah, that's not too embarrassing. Okay. My funny Valentine, sweet comic Valentine, you make me smile with my heart. Oh, of course I'm not recording. I'm so smart. I got too nervous. I'm not used to singing. Okay, here we go. My funny Valentine, sweet comic Valentine, you make me smile with my heart. Okay, so now I have this vocal. It is what it is. Like I said, don't judge me too harshly. It sounds like this. My funny Valentine, sweet comic Valentine. I'm just using this mic. You make me smile with my heart. Okay, now I'm gonna mess with this. So if I turn on flex pitch in Logic, so I had to turn this logo on. I select my channel inside of this window. And if I press flex, now it gives me all these options. So I can mess with the speed, I can mess with the pitch. Let me mess with the speed a little bit. So so I'm just screwing around with the speed. So some of the really low ones are really low. My heart. Valentine, sweet Valentine. Not bad, right? Not bad. So that's the most unsophisticated thing I could do. If I go to flex pitch, this is kind of crazy. So what it's going to do is it scans my audio for pitches. So and I can change individual pitches in different ways. So for example, I could highlight a bunch of stuff. Make it sound really out of tune. My funny Valentine, sweet comic. So I could take all of it and do pitch correction maximum. Sweet comic Valentine, you make me smile with my heart. Sweet comic Valentine, you make me smile with my heart. Yeah, so you get the idea. All of these manipulations are working by changing the speed of the playback or by changing the sample rate in order to remap the samples to a different speed. So it works like this, either by taking a sample and stretching it out, taking a sample and compressing it, you get all these different possible results. Logic has some fun stuff to do with this. And lastly, we have amplitude-based effects. So we used some of this earlier. Compression, limiting, gating, and expansion are the main ones that you should know. So compression takes a signal, it squashes that signal, and then it brings the whole thing up. So, for example, if I have a signal that has a 60 decibel range, so that's a big range. If I apply it, if I send it through a compressor, it will cut it in half in terms of how loud and quiet it can get, the overall dynamic range, and push the whole thing up. This is used to make things sound louder, to bring things out in a mix. So let me use some compression in my mix that I've been doing. I already used some earlier. I'm just going to delete this track here. But let's say the drums here, the overall drum track. Weird. Oh, there we go. So if I send this in, right here is where I can change how much am I going to reduce the dynamic range by. Oh, I'm actually on the wrong one here. So here's my input. You can see how much signal is coming in. So if I take this ratio and turn it up, you can see that I'm squashing the signal down more and more. It has less highs and lows, and they all sound kind of the same volume. Then I can turn this up or down. And you can also, if you listen closely, you can hear the compressor pumping up and down. And this is a really characteristic thing in electronic music production, to have compressor pumping. So another important amplitude-based process is called limiting. So if I turn this limiter on, what it'll do is it'll basically act as a ceiling. It'll take the ceiling and just push it down slightly so that instead of clipping all the time, it will just shave the very quietest, the very loudest things and make them a little bit quieter. You can see I'm still actually clipping here. So I'm going to turn down my limiter a little bit more. Oof, that compressor sounds bad. So the more compression you use, the more unnatural it's going to sound. I'm going to use a lot less than this. Yeah, something like that. It's more natural sounding. Putting it in context with everything. actually, to prevent clipping in my master, I'm going to put a limiter on my master fader. So this will just prevent clipping just a little bit. So if I take the output level and I turn it down to like minus a little bit, now it's not going to clip anymore. So this is kind of a game of seeing how good I need to have a lot of signal. Oh, here we go. That's what's clipping. My master was up. There we go. So you want to have each of your signals loud enough that they can be clearly heard. You want all of their frequencies to blend together so that they make a really nice sound together. And then you want them to be not clipping in individual channels like these. And you don't want them to clip whenever they all add together. So having your levels mixed correctly and using panning can help with that a lot. And then also these plugins such as compression and limiting can really help. So it's actually better to record things right, get it with a good level, and to normalize if you need to, rather than to just use a bunch of compression techniques all the time. These are the different parameters of compression. The important one we haven't talked about is threshold, meaning how loud does a signal have to be for the compressor to turn on? And ratio, which is what's the amount of input versus output. So what's the slope? How much am I squashing my signal by? So there's a cool video about the use of gating. Basically, a gate will take a signal out if it's not playing the level that you want. So let me show you an example here using this track. So I'm going to put a gate on this. So I set it so that now only things that are louder than minus 15 dB will get let through this gate. If it's quiet, it just goes away by 100 decibels. So if you have a really noisy signal, this is a good way to still make it usable, as opposed to this. Let me put a gate on this long on this signal right here. Oh, that loop did not work. So, squash, squash. This is the technique that I was talking about before with the Phil Collins, where you have a snare going through a reverb, pop, and then it getting squashed down with a gate. So connecting together multiple types of DSP can be really effective in creating a new sound. Oh yeah, that's exactly what I wanted to reference. Expanders just take sounds with a narrow dynamic range, and then they make the dynamic range sound bigger. So they make it seem like they're quieter, quiet things, and louder, loud things. This isn't really used anymore. Expanders were really used in the heyday of tape machines to make them sound even better than they were. So let me see if there's anything else I want to do using DSP to this track. I want to take that gate away and put that back down. So I have some distortion. I've got a little bit of compressor. I want to put tape delay on my lead guitar. I've got some different reverbs. I've got EQ. Let me go ahead and EQ my solo guitar too. That's a good idea. I'm going to copy this EQ onto both of my guitars, and I'm going to start EQing the solo guitar. I'm going to turn that delay down a little bit. Make it a little less wet. And actually, I'm going to turn on a new effect. Whenever the solo starts, I'm going to, instead of having the tape delay on, I'm going to turn the tape delay off, and I'm going to turn on a chorus, because I think those sound cool. So let me turn that off, and let me mess around with the chorus. So that's under modulation and chorus. Very 80s. So here's what I've got now. If I press the letter A, it will take me into the automation mode. And I can choose the tape delay and the wet dry mix of the tape delay. And I can choose the chorus and the mix of the chorus. So what I'm going to do is have the chorus come in this section right here. And I'm going to have the tape delay go out. So the tape delay is really only there for the beginning. And let's see what this blend sounds like. So let's listen from the beginning. So here's where my change is going to happen. So new effect for a new section of the song. With that chorus on, it really sounds like kind of Weather Channel-y. But yeah, I think that chorus is a step too far. But as you can see, taking DSP and using it with a discerning ear can really take your session and make it have a lot more flavor. If you overdo it, it can be too much really easily. But this is basically all the DSP that you need as a beginner and the start of how to apply it in a DAW. So that's it for me right now. Thanks, guys.